Hello everyone, welcome to my channel. Today we're going to be studying this very interesting concept of geometry that is known as nets of solid. You need to understand that this topic is only related to 3D shapes. Not only that, but you should also be well familiar with these three words. So again, what does the word vertex means? I will explain this with the help of a diagram as well, but for now just try to understand. So when I say the word vertex or vertices, it's actually a point where two or more two or more edges meet. Edges meet. In a similar way, when I say the word edge or edges, it's actually in simple words just a line segment. Line segment. And similarly, when we talk about the word faces, it's the flat surface of a solid. Now let's see. This shape that you see before me, it's something that we call as a rectangular prism. Rectangular prism. There's also another name for that as well. So it's also known as a cuboid. So you need to realize when I say the word cuboid or rectangular prism, they both have the same meaning. And let's try to discuss these words. So again, what does the word vertex means? In simple words, the word vertex is actually just a corner. So if I ask you how many corners do you see in this diagram? So I can say that's one, that's two, three, four, five, six, seven, but there's one that I can't see, which is actually at the back. That's going to be my eighth corner. So if I ask you how many vertices do we have, you can easily count and say that's going to be eight. In a very similar way, if I ask you how many edges do we have, the word edge means it's this line segment. So that's one, that's two, that's three, this is four, five, six, seven, eight, 9, 10, 11, and 12. So I can say that in this case, how many edges do we have? It's going to be 12. And finally, the word face. So what does the word face means? This flat surface that you see, that's one. So that's one flat surface that you see. Similarly, that's also another flat surface that we can see. So far, that's going to be the first one. That's the second. That's the third. Then there's another one on this side that we can't see. That's going to be the fourth. Then one at the back, five. And then one at the bottom, that's going to be six. So I can say that a total of six faces is what we have in this diagram. You should be able to identify. I don't expect you to learn for every shape. I don't expect you to learn, the case for a cube or anything else. If you understood the concept, you can easily count this in the exam as well. Let me scroll down over here. And now you can see that we have something that is a cube. There is a difference, by the way, in between the word cube and this rectangular prism, which is a cuboid. So when I talk about a cube, all sides are equal. Let's say if I give you this side as 8, that's going to be 8 as well. It's a topic that we'll be discussing later, which is again, surface area and volume. We will discuss that topic probably in some other video. Now, in this case over here, let's count. I feel like it's a better diagram because we can see these dotted lines as well. That means that's the view you don't get. In this case over here, that was actually hidden. But you always have to take that as the case when you're counting the vertices, edges, and faces. Now, in this case over here, if I ask you how many vertices do we have? Similarly, how many edges do we have? And finally, how many faces do we have? I expect all of you to pause this video and try this yourself. All right, now let's see. 1, 2, 3, 4, 5, 6, 7, 8. I can say we have 8 vertices in this case. I'm hoping you also got the same answer. In a similar way, when I say the word edge, that's going to be 1, that's 2, that's 3, that's 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So we have 12 edges. And finally, how many faces do we have? So there's 1, 2, 3, 4, one at the back, 5, and then one at the bottom, that is 6. So this is the case that we have for a cube. Hopefully this makes sense. If this rudimentary concept on how to count the vertices, edges, and faces is clear, we can now move on to the actual topic, that is nets of solid. So again, what does that mean when I say the word nets of solid? It means that we are trying to open up a 3D shape. Let's say we have this cube, and we are trying to open up this box in such a way that, it just comes into a 2D shape. So I'm just trying to make sure that this box, just trying to open up all the sides. Kind of hard to explain in words, but let's see. So if you check out the folder that I've uploaded, you'll see that there is a document that reads nets of solid. And there are these notes that I would expect that you probably just skim over. Do I expect you to learn this? Of course not. So you need to realize in the very first, there's only one page, by the way. In this case, you can see that we have a rectangular prism and that we have a net for that. So if I were to draw that out, probably I'll explain it to you with the help of a online simulation as well. If that is considered as my base. Similarly, this side goes on that side. So you can see there's one that comes over here. And then there's one that comes on this side. That's two. And similarly, one that goes this way. And then we have this side going on that side. And finally, the top, that is this. So if I were to label this out, I can say that's the top. This was the bottom or my base. And the rest are the sides. I know some of you are probably confused at this point in time. So let's try to understand this better. I'll probably be sharing the link to this website as well. Now, again, this is a cube or a cuboid, whatever it is, we don't care about it right now because we are not trying to figure out. Again, the lengths are also not given. So for now, we can see that it's obviously a cube, but let's see. So if you start counting exactly what I did ask you, so if you start counting the faces, you'll realize that it does come out to be 6. Now, in this case, like I said, the word nets me. We are trying to transform a 3D shape into a 2D shape. So let's start opening this up. If I were to open this up, you can see that's exactly what I said. I said, that's this green thing over here, which again is actually red. That's going to be my base. And this is how it opens up. Are you expected to learn this, that the net is going to open this way? Not really. Because in the exam, they might give you a net and they might ask you to label out the name for that certain shape, which is why you can see there's multiple ways in which I can open this up. So I can also open it in this way. I can also open it maybe in this way. So it depends on the kind of question that we are having as to how that net is opened up. The very basic net that you should be familiar with is this one as to how it opens. So again, we have 6 faces. Please do not consider the corner as a vertex because like I said, it's only possible when we talk about a 3D shape. This is no longer a 3D shape. Now we have rectangles. Rectangle is a 2D shape. All right. So hopefully this concept is clear. If you start counting this as well, you'll realize the answer is wrong because let's see. If you call this as a vertex, which is not, so you would say that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's wrong. So you can't do that. You can see that the answer is not going to be the same. Why? Because it's a 2D shape. So hopefully this concept is now clear. In a very similar way, when we talk about the net of a pyramid as well, it opens up in this way. Now, what kind of pyramid is this? It's actually something we call as a square-based pyramid. Square-based pyramid. Why do we call it the square base? Because the base over here is a square. And you can see that we have these as my 4 triangles. Similarly, we have the net of a cylinder as well. So again, that's the top circle, you could say. And then there's a circle at the bottom as well. And this curved path over here, this is actually very important. The curved path, everyone, if you were to open this up, just roll a paper and try to open that up. If you try to unroll the paper, you'll realize you end up getting a rectangle. So that's how the net of a cylinder works. And similarly, this is a cone. So again, we have a circle at the bottom. But again, if we were to open up this curved side that we have for a cone, you can see that it actually forms a sector. For those of you not familiar with what a sector is, we'll probably discuss this in some other video as well. If I were to scroll down over here, you can see this is the same thing that is just written. So we have again a cube, we have a square-based pyramid, then we have a triangular prism. So hopefully this makes sense. That's the base. And if you try to visualize, again, this topic requires a bit of aptitude. So you need to have that understanding on how a 3D shape works. I wouldn't expect you to, as in understand this tetrahedron or similarly hexagonal prism or pentagonal prism, and they don't get really assessed in the exam. But you should know as to, what or how we can actually form a prism out of it. If this concept is clear, let's have a look at one of the past papers. So this over here is a question which reads, the diagram shows the net of a solid. What kind of net do you think this is? I can easily see that it's a square-based pyramid. Square-based pyramid. If you were to write down the word pyramid, that should also classify as the correct answer. And if you see the marking scheme, you'll realize the answer in the marking scheme is written as just pyramid. But again, just try to understand that whenever it comes to these kind of questions, I expect all of you to be very precise. So please write down square-based pyramid or square pyramid. Now, in a similar way, the next part of the question says, write down the number of vertices. All of you need to understand that this over here is a vertex. This over here is a vertex. This is also a vertex. This is also a vertex. This is not a vertex. They all, when they join together, if you try to visualize, when they join together, that's when they form the fifth vertex. So I can say that in this case over here, we have 5 number of vertices. To again make this concept a little more clear, you can look at the second shape that we are having. So again, that's the first vertex, second, third, and then there's one at the back, which we can't see. That's the fourth one. And the fifth one is this apex point, or we can say the fifth vertex. So that is why we can say that in this case, we have 5 vertices. I want to bring back your attention to the very core definition that I made you write down. What exactly is a vertex? It's a point where 2 or more edges meet. But if you check out this open diagram that we had, in this case, when they form together, that's when we can say that, all these edges will meet together. So we are talking about the net of a solid. This is not a solid right now. It's a 2D shape. But when I convert it back into the 3D pyramid that we had, that's when it becomes actually the solid. Hopefully, this concept is clear. In a similar way, let's have a look at another question. You can also find this on the link that I've shared with you. If you click on the folder that says nets of solid, you should be able to see the notes and these past paper questions. Now the question over here says this net is folded to make a triangular prism. Which vertex joins with A? I want you to pause this video and I want you to think very carefully. All right, so let's get started. Now, in this question over here, again, to make you understand the concept a little better, if I were to show you the triangular prism that we had, this is the one. You can see that we had the base and then this triangle over here closes over here. And similarly, this one also closes. And then we had these two sides, depending on how this is made. Now, in a very similar way, let me share this screen with you. So this is again a quite similar shape that we are having. If you look at the diagram, you'll probably be able to realize the resemblance. But the only difference in our diagram that we have in the question is that they have actually made this rectangle right next to this. So they've actually made the rectangle over here. But that doesn't change the concept of the net, right? So if I start closing this, check how this is working. And what kind of triangle is this? It's actually a right triangular prism. Why is it a right triangular prism? Because you can see that we will be having this right angle over here. I'll probably show this to you again. You can see that these two corners over here, this, and this, they all meet at this point. They all connect at this vertex. So this is the one that we have at this certain point. Now that you've understood this concept, let's try to go back to the actual question that we were dealing with. So again, the question over here says, what kind of shape is this? It's a right triangular prism. How do I know this? Because I know that this side will come onto this side will come onto this side. This is going to be the one that's going to be laying in that direction. So it's just going to be coming over here. And then this side over here will be perpendicular up. Yeah. So when you look at this as well, you'll probably realize what I'm talking about. You see this, the one that we have on this side? Yeah. So that's the one we have in this shape. Again, I'm trying to make sure that you understand this. It's kind of hard to explain when it comes to 3D shape. But anyways, so the question reads, which vertices, again, that means it's more than one, join with A. So where's A? A is over here. So I know that this point is going to be on top of this, and it's going to get connected with G and E. So I can easily see that the answer is going to be G and E. Very easy, right? Because like I said, this will come over here, and then you will make this vertical up. Similarly, that's going to be laying flat over here. So they all join at this point. In a very similar way, the question says, which edge join with DE? So I can see that this edge over here is actually going to be joined with, in this case over here, with DE. So they're talking about this one. So we can clearly see that this edge and this edge should be joined together. You can write down the answer as AB or perhaps BA. It doesn't matter how you spell out these alphabets, as in the order doesn't matter, but yes, you can't write down A and B because whenever we talk about edge, what is edge? It's a line segment. And we know that whenever it comes to any O levels question, if two letters are written together, when I say AB, it automatically means it's talking about a line. But when I talk about A and B, that means now we are talking about 2 points. So please do not make this mistake of writing A and B. This will be considered wrong. I hope everyone, this concept is clear. Please do practice some more questions as well. With this, we come to an end. Let's catch up again in the next class. Till then, adios.